So yesterday we started this worksheet. This is a good way to review and get ready for the test tomorrow. On yesterday's worksheet, the front side, we had factoring quadratic trinomials where the a value was 1. There was no number right there, which means you could start out setting up that x and x. And then from there you think what times what is your c value, that if you add together is your b value. There's already a couple of videos recorded on the front side of this worksheet. Today we're gonna work on the back side. So let's flip our paper over. Right here on the back side, we're especially focusing in on factoring quadratic trinomials where the a value is not 1. Okay, where the a value is not 1. So let me just explain, let's say number 34. Now, step 1, when you don't have, when you actually have a number out here, you cannot do the parenthesis xx. You can't do that because you actually have a number. So we need to go through that multi-step process, and I hope everybody follows along right here. Step 1 is to multiply a times c and get a number. So the a value is 2 and the c value is negative 18. So when you multiply 2 times negative 18, you're going to get negative 36. So step 1 is to multiply a times c. Step 2, and I'm writing the instructions here as we go, so you'll know what to do if you go back and look at your notes. Step 2 is to make a list of the multiples. List of the multiples of that number negative 36 that we got on step 1. So how could I get negative 36? So I'm going to start with the number 1. So I'm going to write 1 times negative 36. And then 2 times what? If you don't know, get a calculator. Divide 36 by 2. It'll tell you 18. 3 times what will give you negative 36? 3 times negative 12. 4 times what will give you negative 36? 4 times negative 9. That's right. 5 doesn't work. And 6 times negative 6 gives you negative 36. So those are all the possible ways of getting multiplication of two numbers that give you the answer negative 36. Now the question is, which of these pairs, when I combine them, give you the middle value, the b value, which in this case is negative 9? Well, if I add negative 36, if I add negative 36 and 1, that'll give us a negative 35, and that middle value is obviously not negative 35. Oh yeah, by the way, I forgot to put a negative on the 18 here. I'm sorry. 2 times negative 18. If I add negative 18 plus 2, that'll give me negative 16, and that's not a negative 16. If I add negative 12 plus 3, that will give me a negative 9. So this is the exact pair of numbers that I want for step 2. Then we move on to step 3. And in case you forgot what step 3 is, here's the instructions. You got to set up this situation, ax. It's a binomial times a binomial, and the first part of both binomials will be your ax term. A is 2 with an x. So that's just the instructions, but here's the actual step of doing that. I want to set up parenthesis, ax, that's 2x. And then what do we do with these blank spots? What do we fill in right here? We fill in the numbers from step 2 right into those blank spots, okay? So let's do that. We're going to plug in that pair of numbers, the positive 3 and the negative 12 right in there. And then step 4, the final step, the final magical step, what do? We divide, okay? We divide. Divide by what? Well, whatever you can. So right here on this first binomial, 2 and 3, there's nothing in common. You can't divide by anything. So that binomial is just going to stay the same. So you're going to leave it 2x plus 3. Now, the other binomial, the 2x and the minus 12, you could actually divide both of those by 2. And if you divide both of them by 2, 2x divided by 2, that's a regular x. 12 divided by 2, it's a 6, and it was a minus sign between them. And that's it. We're done. This is the hardest type of factoring there is. I mean, unless you consider factoring by grouping. But I would say this is the most challenging type of factoring there is, and it's not that challenging. The more you practice it, the easier it gets. Now, let's say you do feel not sure about this answer. You could always distribute, combine like terms, and you should get to the original quadratic trinomial that you started with. Okay. So as you can see, I made several practice problems for you right here. If you want, we could try another. You want to try another? Yes. Okay, let's do another. 37. We have 8x squared minus 14x plus 3. Everybody, step 1 is what? Multiply a times c. That's right. Okay. So what is the a value? What is the c value? 3. Okay, so we're multiplying 8 times 3, and that gives us 24. Okay, so that's the answer for step 1. Moving on to step 2, we make a list, right? So everybody write down 2, list of multiples. Okay, list of multiples. Now, how could I get 24? Well, I could go 1 times 24, 2 times 12, 3 times 8 is 24, 4 times 6 is 24, and that's it. There are no other multiplication problems that give you 24 besides changing signs. So then you go through and you start adding them together. 24 plus 1 is 25. That middle value, b, is negative 14, not 25. If you add 2 and 12, that gives you 14. And that middle value is 14, but it's a negative 14, not a positive 14. So we have the right numbers, we just have the wrong signs. So you're going to circle those, and you're going to change that to a negative and change that to a negative. Keep in mind, guys, that you cannot change just one sign. You have to change both signs, okay? So keep that in mind. So right here, we are changing both the 2 and the 12 to a negative 2 and a negative 12. Moving on to step 3. Step 3 is the setup. And how do we set it up? We put the binomials, and we put ax and ax. So let's actually do that. Binomials, 8x and 8x. Why 8? Because a is our 8, 8 is our a. So instead of ax, we put ax. Okay, let's continue on here. So what do I put in these blank spots? The minus 2 and the minus 12. Excellent. So minus 2 right there, minus 12 right there. And in reality, it doesn't matter which one you put first or second, as long as both of those numbers are there. And now for our final step 4, all we do is divide. Okay. So what could we divide that first binomial by? 2. So 8 divided by 2 is 4 with an x. 2 divided by 2 is 1 with a minus sign in between it. And the other one, you could divide 8 and 12. Yes, you could divide them both by 2, but what's a bigger value that you could divide both of these by? 4, right? So let's divide both of those by 4. 8 divided by 4 is 2x, or 8x divided by 4 is 2x. 12 divided by 4 is 3. So there is your answer for number 37, the binomial 4x minus 1 times 2x minus 3. Once again, if you're confused and you want to double check if you actually did it right, go ahead and distribute 4x times 2x. That's 8x squared. 4x times negative 3 is negative 12x. Negative 1 times 2x is negative 2x. Negative 1 times negative 3 is positive 3. And when you combine these x's, the negative 12 and the negative 2, it will give you that middle value, negative 14x. So you can verify that you actually factored it correctly. Okay, so there's a lot more to practice right there. Another 6 questions that you guys could do up there on the top half of the second page. Now the bottom half is solving by applying zero product property. Okay, so zero product property is when you have something times something equals 0, then the first something A could be 0 and or the second something B could be 0. So zero product property allows us to split both of these and set them each equal to 0 and solve. Let's see that in action. Well, first, in order to be able to apply zero product property, you need your equation to have everything on one side and have equal 0 on the right side. So first, let's make it equal 0 by subtracting that number 54. And what you do to one side, you do to the other side. Subtract 54. Okay, and then you're going to rewrite this thing. It's going to read x squared minus 15x minus 54 equals 0. And now you have a quadratic trinomial with the a value of 1, and that allows you to think parenthesis, xx, okay? And then once again, you think what times what is your c value, in this case, negative 54, that if you combine together is your b value, in this case, negative 15. And I always say make a list. How could you get negative 54? 1 times negative 54. 2 times negative 27. 3 times negative 3 times negative 18, I think. 4 times doesn't work. 5 doesn't work. 6 times negative 9 will give you a negative 54. And if you start thinking about which pair of numbers, when you add them, give you that middle value, negative 15, it will be the negative 18 plus 3. That'll give us a negative 15. So this is the correct pair of numbers. You don't have to change any signs. You just put those numbers right here, positive 3, negative 18. It doesn't matter which number goes where. As long as you have both a negative 18 and a positive 3 in those parentheses, you have factored it correctly. However, this was not a factoring question. This was a solving an equation problem. So it's still equal to 0. And all we've done is change the way this looks from a quadratic trinomial to a binomial times a binomial. But now we could apply the zero product property. How could we apply it? Well, right here we have something times something else equaling 0. So that means that the first something, the x plus 3, that could equal 0. And, or the second something, x minus 18, that could equal 0. These are two simple one-step equations that you could solve. All you have to do is subtract 3, x equals negative 3 is one answer, and the other one plus 18, x equals positive 18 is the other answer. So those are both your answers, and you could type them in on quizzes, x equals negative 3, comma, x equals negative 18 with no spaces between your terms, and that's how you'll get full credit on those questions. So there will be some where, like all of these on the worksheet, I do apologize, all of these on the worksheet are quadratic trinomials, and you're going to be able to factor all of them and be able to get the binomial times the binomial equaling 0, then you could split them and solve. But there is a different type of similar question on the actual test. It goes something like this. Let's say I had a x, let's say 2x to the second minus 18x, yeah, equals 0. So if I wanted to solve this right here, what could I do? Well, it's already equal to 0. That's great. Everything's on the left side. But I need a factor, and it's not a quadratic trinomial. So any ideas on how to factor the left side of this equation that I just made up right now? What's the first type of factoring you're supposed to always try? GCF. So could I pull out a GCF from those two terms? What's in common here and there? 2 and an x, right? So you could pull out a 2 from the 2 and a 2 from the 18, and you could also pull out an x from this one and from that one. So your GCF is 2x. So now let's think, 2x times what would get me back to a 2x squared? X, that's right. How about 2x times what gets me back to a negative 18x? Negative 9, perfect. And this is equal to 0. So all I've done is change it from a binomial to a monomial times a binomial, right? I factored it. Now I have multiplication. Why do I want multiplication? Because when you have something times something else equals 0, then that first something, 2x, could be equal to 0. And or the second something, x minus 9, that could also be set equal to 0. And you solve both of them and you get your two answers. So the first answer is pretty simple. It says 2 times x, so divide by 2, divide by 2. That cancels out. X equals 0 divided by anything is still 0. So that's one answer. The other one, plus 9, you got x equals 9. Cool? Excellent. All right, so this worksheet is a great way to get ready for tomorrow's retake test. I also recommend going back to last week's practice test. A lot of us haven't done that yet, and you have a 0 right now on that homework grade. Make sure you finish that practice test. There's also one more type of thing I would like to go over right here with you guys that I don't have on this worksheet, but that will be on the test, that was on the practice test, that was on last week's test, and that was different factoring quadratic trinomials that were perfect square quadratic trinomials and perfect square quadratic binomials, or difference of two squares. So if you have a perfect square term in the front and a perfect square term in the back, right, and there is a minus sign between it, then you could square root them and plug them into your factored form answer format. So parenthesis. Think about what the square root of 9x squared is. What's the square root of 9x squared? 3 with an x, right? And you put that as the first part of both binomials. And then you go back over here and you say the square root of 25. What's the square root of 25? 5. So you put a 5 right there and a 5 right there. And of course, in order for you to end up with a negative 25, this has to be a positive 5 and a negative 5, or a negative 5 and a positive 5. But there's no way that both of them are going to be positives, because that will not give you a negative 25. There's no way that both of them will be negative, because that would also give you a positive 25, not a negative 25. So in order to get a negative 25 at the very end, one has to be positive and one has to be negative. It doesn't matter which one's positive or which one's negative. Sound good? So there will be some like this, even though it didn't really pop out on this worksheet, there will be some like this on the retake tomorrow, just like last week. Alrighty, guys, I want to stop recording, and hopefully you guys continue working on this worksheet. Good luck.